Okay, so this is our third video on factorization, and here we're going to look at non-monic quadratic trinomials. So quadratic in that the highest power of x is x squared, trinomial in that it has three terms, an x squared term, an x term, and a constant term, and non-monic in that the coefficient of x squared is going to be something other than 1. It might be -1, it might be 2, it might be 7 billion, something other than 1. Although we probably won't be factorising a quadratic trinomial where a is 7 billion by hand. Okay, so I'm sure that you've looked at how to do these before. I'm going to show you a method that I prefer personally, and I would encourage, if you haven't seen it before, that you try some factorizations using this method and at least be able to make an informed decision of what you prefer. Now, some of you will be comfortable with something that I've referred to in the previous video called the cross method, or referred to as the cross method. And I want to be clear that the cross method is really just a way of setting out your trial. It's trial and error, and it's just a way of setting out that trial and error. So trial and error is fine where there aren't too many options to trial. But trial and error, you could be there a very long time if there are a lot of options to trial, okay? And that's where the process that I'm going to show you today will work in a similar way every single time, no matter whether there are lots of options to trial or not many options to trial. So it's a bit more, it's a process that you can use all the time, where you might find that the cross method fails you occasionally, just because there are too many options and you get lost in it. Okay, so an example of a non-monic quadratic is 4x squared plus 7x plus 3. It's non-monic because it's 4 times x squared. These are much harder to factorize because I already started off by saying when we have monic quadratics, so let's say we have, x squared plus 5x plus 6, immediately we know the only way that we got 1x squared was to have x and x at the start of the brackets. And then it really just becomes about those two numbers. And you know those two numbers multiply to give you 6, and you know those two numbers add to give you 5. And so it's always possible to work it out. Okay. When it's a non-monic quadratic, so all of a sudden this example I've given you here, it's got a 4 at the start now. Now there's a couple of different ways to get 4x squared. We might have 4x and x. We might have 2x and 2x. And obviously it could also be x and 4x. Okay? And then again, we still know these two numbers in the bracket are going to have to multiply to give 3, but they no longer add to give 7. And so it's not as easy to find the two numbers. Okay, multiplying to give 3, that's fine. It could be plus 1 and plus 1 and plus 3, or minus 1 and minus 3. So that means we could have plus 1 plus 3, but we could also have plus 3 and plus 1. We can have plus 1 and plus 3, which is the same. Or we could have, and so there's a few different options to test here. Now, not a lot of options, and that's because 3 is a prime number, so it doesn't have a lot of factors, okay? But if you had 3 was, 12, and it's got a lot of factors as well, all of a sudden you've got quite a lot of things to potentially test using your trial and error method. So as I said, we know that the first two terms in the bracket are going to multiply to give 4x squared. So they have to be 4x and an x, or 2x and 2x. Okay. We know that the second two numbers are going to multiply to give positive 3. So they have to be plus 3 and plus 1, or negative 3 and negative 1. Okay. But it's then how do we utilise this 7, and it's not as simple as I said as previously. And that's because, let's look at this more generally before we have a look at the specific example. So what we're looking at is potentially we might have non-monic quadratics could expand to something as complicated as this, where you've got 4 different numbers involved. Now, when you expand this out, you're going to get, I'll try and do it in the one step, you're going to get AC, and I'll do it in 2, ACX squared plus ADX plus BCX plus BD. So ACX squared plus AD plus BC times X plus BD. So as I said before, these two numbers are the two numbers in the brackets multiplied together. The two starting terms in the brackets multiplying together give you this. Okay, but the challenge with a non-monic quadratic is that that middle constant term involves all 4 numbers in the brackets, and so it's no longer as simple as saying, oh, it's just about factors of 3 that add up to 7, okay, because the 4 is also interfering with it. So what we actually want to do is we need to create a number that involves all of A, D, B and C, and we can do that by multiplying that number by that number, and we essentially get A, B, C, D. And then it's about factors of that number that add up to that number. Okay, so that's going to be the key here. So let's talk through the process, and then you just need to practice it. So the first thing we want to do is multiply the coefficient of x squared by the constant term. 4 times 3 gives 12. What we now have is a number that involves 12, is a product of all 4 numbers that are involved in our brackets. Okay, we don't know what they are yet, but they're all involved in 12. Okay. Then what we're looking for is factors of 12 that add up to 7, because we also know that all 4 factors are involved in that number 7 as well. Okay. So factors of 12 that add up to 7, that's going to be plus 4 and plus 3, or plus 3 and plus 4, it's the same. Then what we want to do is we want to rewrite, so I've done step 2, look for factors of the number found in step 1, so factors of 12 that sum to give the coefficient of x, factors of 12 that sum to give 7, we've done that. Step 3, rewrite the x term as 2 terms using the factors identified at step 2. So now what we want to do is, instead of there being a plus 7x here, we're going to split it up using the factors that we've just found here. So I'm instead going to write it as plus 4x and plus 3x. So it still equals 7x, I'm just breaking it up. We've still got the 4x squared at the beginning, and we've still got the plus 3 at the end. And then we're going to use factorisation by grouping, which we looked at 2 videos ago. So we're going to isolate the first 2 terms and isolate the second 2 terms and factorise them separately. 4x is a common factor, x plus 1. And in the second 2 terms, 3 is a common factor, leaving us with x plus 1. Now, if we take out our common factor now is the bracket, x plus 1, we get left with 4x plus 3. Now, if we'd chosen to write these 2 terms as plus 3x and plus 4x, we would also have still got to that answer. Okay, we would have had a different looking line at this step here. In fact, I'll write it this way. So if we instead did 4x squared and I wrote it as plus 3x and plus 4x, now I would probably never choose to do that, because I make a choice about how I'm going to order these 2 numbers based on the fact I know I'm going to factorise by grouping. So I want to get as many common factors as I can. So it would be nicer to match the 4x with the 4x squared. But you should always be able to get there if you put them in the other way around. Common factors between 4x squared and 3x is only x. We get 4x plus 3. And then there's no common factors here, so it's just one lot of 4x plus 3. And so we still get to 4x plus 3 now is the common bracket, and when we take that out, we're left with x plus 1. So you still get to the same place. It doesn't matter which order that you put your, how you break up your middle term. You need to use these factors of 12 to break up your middle term, but it doesn't matter which order you do it in. Okay, let's just work through some examples. Fully factorise each of the following. So again, our initial processes don't go out of the way. If it's a simple quadratic, we're not going to do this 4-step process. We're going to just look for factors of the last number that add up to the middle number and immediately write down the answer. If there's a common factor we could take out, we're absolutely going to take that out and make it easier. Then it might be a simple quadratic, a Monic Quadratic rather than a non-monic. So all those things are still going to fit. There's no common factors here. It's a non-monic quadratic, and so we need to use this process. So we're going to do 4 times negative 6, which gives us negative 24. Then we're looking for factors of negative 24 that add up to positive 5. So I'm thinking about 8 and 3. I'm going to need it to be positive 8 and negative 3 to get it to add up to positive 5. Okay, so I'm going to leave my 4x squared, I'm going to leave my minus 6 at the end, and I'm now going to be splitting up this middle term, so rewriting 5x. So it is now, and I can either choose to write minus 3x and plus 8x, but I actually like the factors better the other way around, so I'm going to write it as plus 8x minus 3x, because there's good common factors between those first 2 terms and good common factors in those second 2 terms. So common factor in the first 2 terms is 4x, which leaves me with x plus 2. Common factors in the second 2 terms, negative 3, which leaves me with x plus 2. I know I'm on the right track because the brackets are the same. If the brackets are not the same, you've made a mistake. Okay, they must be the same at this point. You've picked the wrong numbers, you didn't factorise properly, something's happened, but the brackets should always be the same. So if they're not, something's not right, go back and start again. So x plus 2 is the common factor, and we get left with 4x minus 3. Okay, second example. No common factors, so it's a non-monic quadratic. 2 times 4 is 8. We're looking for factors of 8 that add up to 9. That's just going to be 1 and 8. Positive 1 and positive 8. So we're now going to break up the 9x. 9x is now going to become plus 1x plus 8x. Now you could write this whichever way around you want. I might go with plus x plus 8x because I like the 8 with the 4, but it would work perfectly fine. We'll get to the same answer in the end if you wrote it as plus 8x plus 1x. Okay, grouping. Looking at the first two terms, there's only x in common there. So we have 2x plus 1. And looking at the second two terms, positive 4 is in common there, which also leaves us with 2x plus 1. So we know we're on the right track. The brackets are the same. Take that out as a common factor. 2x plus 1 times x plus 4, fully factorised. Okay, question 3, we need to be a bit careful here because the terms aren't in the right order. So it's important when we talk about, that's why I don't tend to talk about the last number and the middle number. I tend to talk about the coefficient of x and the constant term because they don't necessarily have to be written in the middle and at the end. However, it's easier in our brains if we have the same kind of process. So we're going to rewrite it to make sure that we've got the terms in order with the x squared term first. So that's negative 6x squared. Then the x term plus 7x. And then the constant term plus 3. Alright, common factors? No. Okay, there's 3's in common between 6 and 3, but it doesn't go into 7. So there's no common factors here. So it's a non-monic quadratic. So we're going to do negative 6, the coefficient of x squared, times positive 3, the constant term, to get negative 18. And we are looking for factors of negative 18 that add up to 7. So I'm thinking about 9 and 2. One of them has to be negative to multiply to give negative 18. And they're going to need to add up to positive 7. So we're going to need positive 9 and negative 2. Okay, so then we want to break up our 7x, our middle term. And we could either write it as plus 9x minus 2x or minus 2x plus 9x. I might go with minus 2x plus 9x, because then there's going to be some common factors with both pairs of numbers. Okay, first two terms, highest common factor is negative 2x. And so we're going to have 3x take away 1. Common factors in the second two terms are plus 3, and we get 3x. Oh no, it's not, sorry, it's not take away 1 in the first bracket because we took out that negative, so it's 3x plus 1. So again, that was a moment where I realised my two brackets weren't going to be the same, and therefore I made a mistake somewhere. And it was simply just in this first bracket. With this negative here, we've factored it out. Okay, so now the bracket's the same. 3x plus 1 is the common factor, and we're left with negative 2x plus 3. Now again, we don't really usually like that negative at the start of that bracket, so a couple of different options. You might see this answer written as 3 minus 2x, or you might see that negative taken out, and so it's written as 2x minus 3. But all of those are the same thing, and they're all fully factorised. Okay, part 4. Everything's in order, but the first thing that's screaming at me is there's a common factor of 12. So if I take out the 12, I get x squared plus 2x plus 1, and I have a monic quadratic, so I don't need this lengthy process. Okay, straight away I can write down my answer here, because when it's a monic quadratic, I know it's just going to be x plus a number, x plus a number. I know it's going to be numbers that multiply to give positive 1 and add to give positive 2. So the only way that will work is if we have plus 1 and plus 1. And so actually this is x plus 1 all squared. And if you recognise that perfect square pattern, you might have been able to go straight to this answer here. And you would need to write it as that rather than x plus 1 times x plus 1. Okay, so some practice for factorising non-monic quadratics. If you haven't tried this method before, I encourage you to give it a go with a couple of them and just practice it and make sure that you're familiar with it, so that if your cross method does fail you because there's too many factors and you can't find which numbers you need, then you've got another method to fall back on. Or you might find in having practiced it that you actually prefer this method to your trial and error method. Okay, but the work today, a couple of questions from the building understanding section and then exercise 5D.